Welcome. Today, we will take a look at how we can build reliable data science transformations using Trel. So, what is Trel? Trel is a data ops and automation platform that solves ETL and data transformation with a focus on improving the quality and reliability of transformations. The features that Trel offers supersedes those offered by Airflow, dbt, and Delta Lake. In addition, it provides facilities such as a data catalog. It does lifecycle management and data governance, as well as time travel. All this is possible due to a key innovation called catalog based dependency. In this talk, we will take a look at catalog based dependency. Then we will look at some data science capabilities. We will see how we can convert data science notebooks to jobs. We will see how we can grow jobs into a complex data mesh, how we can parameterize jobs and do A/B testing on the parameters, as well as how we can do A/B testing of complex transformation pipelines with code of a branch. So, to understand catalog based dependency, we must understand the catalog. Let's say we have a list of customers as of January 1st, 2022 in some path. How do we catalog it? The Trell data catalog is a generalization of a spreadsheet where we store the paths of the data in the cells. Something like this, where we have the date in the rows and the type of the data set in the columns. So this path can be put right here. So a spreadsheet like this defines a two-dimensional space where we can store URIs. But this two-dimensional space is not enough for expressing all the complex nature of data in a data warehouse or a data transformation pipeline. So we have to generalize this. So the first step is to change the format into an enumeration of the rows. So here, the type of the dataset is called dataset class, and the time of the dataset is called instance timestamp. And then we generalize the table by adding four more dimensions. The first dimension we add is instance prefix, which is null. The second dimension we add is instance timestamp precision, which refers to the precision of the instance timestamp, which is day precision. Then we also add a repository, which is the data lake. These three dimensions aren't going to change in the examples that we are given, so we can largely ignore it. The last dimension we add is the label, which is master. This corresponds to the environment for the dataset, and this is primarily what we use for our A/B testing. So, how do we use the catalog based dependency to build jobs? Let's say we have a requirement to build a job for report 1, which has to read sales data and inventory data, and the output will be named report 1 as well. As of now, the data catalog has these data sets. We have sales data sets and we have inventory data sets. So when we run report 1 for a specific date, let's say 220101, what data sets does it need? Obviously, it is these. Unlike other systems where the selection of these paths is based on the URI itself, the unique innovation in Trel is that these URIs are selected based on these dimensions. These dimensions are the identity of the URI. To run this task, we need two datasets of these specific identities from the catalog. Similarly, if we were to run the task for 1, 2, then we will be needing datasets with these identities. The set of identities needed for a task is called its schedule. It looks like the schedule is all about input selection, but it is more. The schedule determines when the job can actually run. Trell monitors the data catalog for new entries that complete the schedules of any task and runs those tasks immediately. So the schedule actually determines when the job can run. This mechanism is also 100% reactive. In addition, being based on data availability, this mechanism is ideal for data transformation pipelines. So, how do we implement the selection of these identities from the catalog? To help with this, Trel provides a number of scheduling classes. So, a scheduling class implements a pattern of identities. A job configures a scheduling class to make a set of schedules, and Trel runs tasks when all the inputs are available. In general, we find that there are three types of class scheduling classes. One is the transform type, second is the update type, and third is the collect type. In this presentation, we will take a look at a number of examples consisting of transform and update. So let's take a look at how we can build jobs. If you want to convert some of your existing code, such as a data science notebook, into a Trello job, then you have to go through three steps. The first one is to remove resource allocation, such as spinning up a cluster. Of course, if you are a this is a data science notebook, then that would not be required. But you have to do this because Trello offers powerful plugins that can take care of this step. The second thing is to refactor your code so that you avoid changing the inputs. The reasoning behind this is that Trell is built around the concept of immutable data. That means once a data set is created and it has been added to the catalog with some identity, we no longer change the data in that path. Because if you do, that will cause the data to be inconsistent with its identity. Trell will give such a job at least two paths: the original input and the output path where the updated data should go. To do the refactor, we change inserts to unions and deletes to filters. And it is just like an insert and delete. We will write the final result to the output path. The last step is to remove hard-coded data paths from your code, as data organization is something the data catalog is responsible for. So we replace all the paths with variables and assign those variables right in the beginning of your code. So if you make all these changes, your code will look something like this. As you can see, all the paths are in the beginning, and we can now just process the input data, compute the output, and write it to the output path. Next, we just have to make a few more changes to turn this into a complete Trell job. The key thing to note here is that Trell will give you all the information that is required to run your task. You have to change your code to use it. So this information is stored in a YAML file along with your code. You can either parse the YAML file or use the helper function getargs from the Trell SDK to get this information. Then you can use this information to get details regarding the inputs and outputs. You will assign the URIs of the specified inputs and outputs to the appropriate variables. You may need to use other information from the YAML file in some cases, but in this simple skeleton that we are not doing anything. So this is the final code. Of course, it does look too simple. That is because a lot of the work will be done by Trell based on your registration file. So let's take a look at that. So the first thing you see in the registration file is the name of the job. Next is the execution profile. This is a plugin that is responsible for running your job. It does a lot of the heavy lifting, such as checking out your code, allocating resources, etc. This is followed by some specification for the resources required for this job. The next section specifies where to find the source code. This will, of course, be used by the profile for checking out your code and running it. Finally, we have the scheduling information. We see a class specified here and some configuration. The class is called schedule instance. Now, the goal of this parameterized scheduling class is to produce a set of schedules. Each schedule consists of some scheduling info as well as a set of identities of inputs. As we have seen before, each identity is a point in the six-dimensional catalog space. So let's take a look at the schedule info. The first is the schedule ID. This is a unique string for the schedule and can be used to run the schedule. In our examples, it's a string like 2022-0101, but it can have a few more information in it. The rest of the schedule info forms an anchor for the inputs. The schedule info for all the schedules can be populated from the configuration. So schedule instance prefix is none because we didn't specify any here. Schedule instance timestamp precision is D. Schedule instance label is master. And schedule instance timestamp follows the cron constraint and thus forming a set. So how does input identities derive from this schedule info? In this case, for the single instance scheduler, all inputs must share the same instance and it will match the schedule info. So that is, these three dimensions will be exactly same as the schedule info for all the input identities. Additionally, default label will match the schedule info as well by default. This is now, that is 4 out of 6 dimensions. The remaining we have dataset class, and this will come out of depends on. So we basically have one value sales, and repository will come out of the repository map based on the dataset class. Here we have just DL. Now that is all 6 dimensions. So this section covers the output generation. Again, we have to come up with 6 dimensions. It says here that there is one output with dataset class sales stats. The rest of the dimensions of the identity depend on the schedule info and the repository inherited from the inputs. So that is 4 plus 1, 5 plus 1, 6. So all the dimensions are specified here as well. Now you can use this registration file to register this job. Then you can run the job by giving Trel the job name and the schedule ID. Next, let's take a look at how we can build a data mesh from jobs. In Trel, a job is the largest and the smallest unit of transformation. This means that you do not actually design a transformation mesh. So then how do you make one? Well, a job can consume any dataset on the catalog and all of its outputs are also added to the catalog. If you keep creating new jobs, then a data mesh will emerge organically. To better understand this, let us examine a set of requests that a data scientist faces. Let us say you have just been hired as a data scientist into an e-commerce company, and they have just set up a data warehouse consisting of 3 datasets. The first one is customers, which is loaded daily and consists of all the current customers. The second one is sales, also loaded daily, consisting of daily sales, and activity, also loaded daily, consisting of daily activity. Great. So the first request for you is, hey, can you generate sales stats? So there are 2 ways you can do this. The first is you can query 1 year or 2 years of sales data, the raw sales data, which is cataloged by day, and generate all the stats from scratch, and have a complete data set that gets fully replaced daily. Or you can have the sales stats as of yesterday and then use today's sales information and append the sales statistics to the sales stats. So you may be forced to do the former if the kind of statistic that you're generating cannot be incrementally grown. But if it can be incrementally grown, then you have the second option. The second option is what we implement here. And for this pattern, which is the update pattern, you have this class called period, data scheduling class called periodic. So the information that we want to provide it to do this pattern is depends on and self depends on. So depends on says the data set which we are going to use to update, and self depends on is the data set that is being updated. And with just these 2 pieces of information along with this cron constraint, which I said this is going to be run daily, we get this schedule, which is sales for what, this is one of the valid schedules. Sales for 1 2 and sales stats for 1 1 is a valid schedule, and the output will become sales stats for 1 2. So there is a question of where did the first sales stats come from for the update. And the answer to that is you will have to write the code. There are a few options. You can either have a blank data be registered as sales stats, and your code can just deal with blank data, or you can run that first job, the kickoff job, without sales stats. You can ask Trel to you know ignore the fact that it is missing. And so as long as your business logic can tolerate the sales stats being null and knows what to do with it, knows, then it can know that it's the first time it's being run, so it will just generate the sales stats from the sales data alone. Okay, so the next request is, hey, can you please generate some sales forecasting? That's pretty straightforward. It can be generated directly from sales stats using some time series forecasting, and you implement that. uh, the scheduling is just single instance that we have seen before, and which generates the sales forecast. So after this, the upper management says, hey, sales forecast is great, but we would like some breakdown of the sales based on the type of customer. So taking in this request, you realize that you actually don't have too much insights into the customers other than what is present in this customers table, which is not a lot. So you decide to have a more detailed customer profile for insights. um, so you decide to use the information from customers, and you decide to use some information from activity, but you also decide to get some demographics information which you decide to buy. So you buy the demographics information. It is showing up in S3 in some folders, date based folders, but not daily, because that information doesn't change too frequently, let's say once every 3 months or 6 months. And you have a sensor on that folder which will detect new folders, a sensor on the root folder which will detect new date based folders for each drop and add it to the catalog. So then your catalog looks like this with the demographics information, and then you can write your customer profile. Here as well, you have the choice. Hey, do you want to write the customer profile by looking at all the customers and all the recent activity and demographics and just build the customer profile? That's actually not too bad. You probably don't have to look back too far, like 60 days or 90 days. But here I've again gone with the periodic pattern. Uh, okay, so the one thing to note is the periodic pattern only really is covering customers and activity as inputs, and the customer profile as the updated one. So what about the demographics? So the problem with the demographics is that data set is not updated daily. So if it was part of depends on, this job will not run because it is missing demographics as a daily drop. And for that reason, we put demographics in its own section called other data sets, where it is separated from the scheduling part. And what we do is we look for the schedule, we look for an entry in the catalog, and we look for the entries in the catalog and find the one which is the largest, the newest instance timestamp, and that is what is picked for this job. Okay, so now that we have the cluster customer profile, we are ready to do the sales profile, and it's pretty straightforward. Again, periodic. You are updating sales based on the daily sales as well as the latest customer profile, which should have already run. So just by saying that you want the customer profile, which means that if you're going to try to run for 1 2, it's going to require customer profile for 1 2, which requires that the customer profile job for 1 2 should have already run. And that is how you kind of connect these jobs indirectly through their data sets. So sales by profile cannot run until customer profile actually runs. Okay, so next, now that sales by profile is done, the upper management would like to see some information regarding the activity as well, some activity stats, how many people are using it, or how many clicking, so on and so forth. So you use the, again, recursive formulation, periodic scheduling class, pretty straightforward. Okay, so then you have a little more somewhat different of a request. So what the upper management said is, hey, um, we have we are getting some idea about the activity, but what we really want to know is, what is the user trying to do when you're using our website. So is there some way in which we can look at the sales and activity and kind of predict what is their intention here? Are they trying to make a buy? Are they just browsing? What are they trying to buy? So if we could get an intention model, then we can tune our website to perform better, to improve our sales. Great, no problem. So here you want, this is definitely not an incremental situation. You have to use all the data available as long as is relevant. So you say you decided to load, use 30 days of sales, 90 days of sales, and 90 days of activity. Now, as I mentioned before earlier, the schedule timestamp is based on the cron schedule instance timestamp is based on the cron constraint, and it serves as an anchor to the input selection. So minus 90 basically means minus 90 periods, including the schedule instance timestamp period. So you get 90 days of data. Those 90 days where the schedule instance timestamp is the last one is the dates that you're picking. Same for activity as well, and you generate intention models, and its date will be the newest date for which you have sales. Okay, so at this point, upper management is pretty happy, and they want to increase sales using another approach, which is advertising. So they decided to try some email marketing, and for this, they have started some campaigns. And for each campaign, they have a list of emails that they have compiled that they are flighting it, that they're using to flight the campaign. And what the upper management wants to see is some conversions. How effective is this campaign? Is it really leading to lift, and so on and so forth? So for this, of course, you need those segments before you can do anything. So the segments are being dropped daily into our data lake, and you have a sensor that is detecting it and cataloging it as new segments. It consists of all the new segments that were with which new campaigns were started, and has the information regarding those campaigns as well. Okay, so this data set is not enough for us to actually do, because what we need is, we need more than one day. We kind of need the set of all segments that were used, that are have been launched so far. So what we do is we do merge segments and get cumulative segments over here. Okay, periodic pattern, no big deal. So now that we have this merged segments, we write our job campaign conversions, which uses the latest set of segments that we have, as well as historic sales. So here we probably don't have to go too far, because we have segments. We're not really that interested in segments that ran like 6 months ago or something. So we're just going to have the segment information. We're just going to do this conversions for recent segments, and so it's enough for us to have sales data of the recent time frame, so 180 days. And we really care about just before the campaign and after the campaign, what was the sales for this segment and vice versa. So this much information is enough, and so you can now compute campaign conversions. Okay, so so far what we have seen is we have built a number of jobs, and to build each of them, we just looked at the data in the catalog, and then we came up with a schedule, some configuration for a scheduling class, which builds a schedule, and then we are just able to automate it. Now, without really trying, we actually built a somewhat complex mesh with clear indications of certain popular data sets, and some which are just not used that frequently. And this is the strength of Trel, that such a complex mesh with extensive data reuse, where people can just shop for the best data available and then just use it to build their own data set. This just happens organically and without any limits. Okay, so next, let's take a look at how we can parameterize data science jobs. So when you want to parameterize a Trel job, the first thing you want to do is expose the parameters to Trel through the command line. Trel runs your jobs by running them as a Python script, so Python your job.py. So when you expose any parameters on that command line, you can have Trel add them from the registration file. So that is the second part. Add parameters that you want in the registration file, and Trel will add them to your to the command line of your code when it runs it. The third one is you can also um, override the parameters or append or override parameters from the Trel execute command line. So when you say Trel execute this job, you can say you want something to be added to the command line. Okay, so let's take a look at look at an example. So let's say you want to add a parameter loops. The best option is to just use the Python arg parser and add it to your program's command line. And if you want in the registration file, you would use this Trel parameter called execution.additional arguments and give it a list of strings, and this will go to your program. Um, from the command line, you can set execution.additional arguments CLI for additional parameters to be added to your program's command line, or you can set additional arguments alone, execution.additional arguments, and it will replace the parameters that are set in the registration file. So how do we use this for A/B testing? When Trel runs a schedule job, it runs it using the schedule ID alone. So a scheduled run is equivalent to running the job with I like this Trel execute job name and schedule ID. So what we want to do is we want to A/B test this run with a this task with a different parameter, and this is how we do it. Trel execute sales forecast same schedule ID, but then you set additional arguments and then you give it some different parameter that you want to do. Okay, but also you want to provide a output label temp.loops30. This is because the scheduled job is going to generate data sets with master. If you do not provide this, your alternate run, your B run, is also going to generate a data set with master. So both the outputs is going to have the same identity. And in Trel, if two data sets have the same identity, then the newer one is going to suppress the older one, and you will only see one of them. So we want to give this one a different identity, and you will use the label for these. You'll change the label to give it a different identity, and we're going to set it to temp.loops30. The temp dot is there in case we have a lifecycle module where you may have configured some lifecycle for labels with the temp dot star pattern. Let's say delete it after 30 days, and so just by naming the label temp dot something, it will automatically get deleted after some time. Great. So next, let's take a look at how we can do A/B testing of a complete data, complete portion of the data pipeline. So let's say more than one job. How does that work? Our goal here is to evaluate an improvement to the customer profile. This improvement is committed to the customer profile branch, customer profile V2 branch in Git. And to do this evaluation, what we're going to do is we're going to automate the customer profile with branch code in a separate label. And we're going to run sales by profile in a separate label in that same label as well. And it will use the new customer profile, and we will evaluate the changes to the sales by profile, and we'll see if the changes that we made to the code is reflected in the quality of the sales by profile dataset. Okay, so first let's take a look at what is currently running in production. We have customer by profile. This is the periodic pattern, if you recall, which means that it's reading 1 1 of customer profile, 1 2, and 1 2 of customers and activity to generate 1 2 of customer profile. So we don't want to change the existing job. What we want to do is add a new job which behaves like this. The new customer profile, let's look at the second one, not the first one. So the second task of second and all following tasks of customer profile will read from customers and activity from master, but it will read customer profile from the customer profile v2 label. And this new job will also be running the branch code, and it will generate customer profile into the uh, customer profile v2 label as well. The first one is a little special because it has no customer profile 1 1 to read from in this branch, in this label. So it's going to switch to the one from master only for one time, but all the later ones will use the one from this label. Okay, so similarly, for sales by profile, again, it's a periodic pattern on where sales and customer profile update sales by profile. And the job that we want to add is actually running master branch, because sales by profile is the same code. The defining difference is that it's reading from the new customer profile. Again, here for the first job, we have the issue of sales by profile missing. So we're going to use the sales by profile from master, and then everything else is going to be these two data sets are still going to be from customer profile v2, and the sales is still going to be from master. So let's see how to make these changes. The one thing to note is we are going to write the registration file for the second and following job, and we are going to treat the first job as a special case. Okay, so let's look at the customer profile. This is the customer profile which is in the master branch, and this is the new one that we are registering. So the changes are in the name. So we say dot customer profile v2 for clarification, so that we know which one is which. We change the branch. Obviously, this is the branch that we are testing. We officially changed the label of the schedule label of the new job into customer profile v2. But our problem is that we don't want customers, activity, or demographics from this branch. We want all of them to come from master. So first, let's look at how we do that for demographics. Well, here you have to explicitly specify master anyways. So then all we have to do is not change it. But what about customers and activity? For this, we have this option called prefix label selection, which gives us tremendous amount of flexibility in which labels are chosen for each scheduling class, so each dataset class. So we say for this schedule label customer profile v2, and for this schedule prefix null, we want activity to have null prefix and master label. And this is the case that we have configured anyway. This is the only case we are doing, and then this is the only this will be the valid label for these dataset classes. Okay, and next let's take a look at sales by profile. Sales by profile, it's a little simpler. We change the name. We don't change the branch of the code because we want this. Do want the main code. We change the label, and we do use prefix label selection, but only for sales, because we do want to use the customer profile from customer profile v2. Okay, so this takes care of everything but that first runs. So let's actually do the first runs manually by picking and choosing the inputs that we actually want. So Trel execute customer profile v2, customers, activity, customer profile, all of it from the master branch, demographics from master branch. Now, if we just say just do it, it will come. Trel will complain. It'll say that this is not a valid schedule, and I need to run a valid schedule. So then you explicitly say, don't, just do what I'm telling you. And then you have to help it out by saying this this is the schedule ID for this task that I'm asking. Okay, and similarly you can do sales by profile by forcing the sales by profile to master, asking it to, and forcing the matter and giving the schedule ID. Great. At the end of this, your data catalog will look something like this. So starting from 1 2, you will have access to customer profile for two different branches, master and customer profile v2. And you can compare these two data sets apples to apples. Now, one main question is, what is today's date? Is today's date 1 2 or is it 1 3? Well, it doesn't matter. Actually, today could be June. That means that even if today is June, you can register your job to start from January 2nd. That's because it all depends upon which was that first job that you ran, the kickoff job. You ran the kickoff job for January 2nd, and that is from when the pipeline starts. If you run the kickoff job for March 1st, then that's when the pipeline starts. So that is under your control. And you are actually able to pick and choose the date without worrying about when is the start date, when is the current date, because all the data, all the historical data is cataloged in the catalog, and is immutable, which means that it didn't change at all since the time it was actually entered. So this gives you complete time travel capabilities. So what happens when you actually kick it off for 1.2? Well, it doesn't stop until you get to the latest date. So the alternate customer profile will keep, and the alternate sales profile, the two new jobs that you registered, will keep running until it catches up with the production job, because they can run any if a production job can run, then this alternate jobs can also run. So it's going to immediately start running the pipeline until all 5 months are caught up, and then the latest data set is in June. So when you compare the June master and customer profile v2 datasets, then you're looking at the impact of your code change over a period of 5 months, and you can be guaranteed that that comparison is exactly accurate, and there will be no flaws in the middle, no compromises somewhere in the middle, where where you have to say, I ran the experiment, I got some results, and I'm mostly sure it's going to be the same if you put it in production. No, it's going to be exactly the same if you put it in production. And that is one of the strengths, one of the main strengths of all the decisions that gone into the design of Trel. So if you are like whatever you have heard so far, what more can you do? So what I suggest is take a look at our documentation tutorials. Then we have a video on how to create a dashboarding pipeline that will give you more of a practical introduction to building data sets and jobs in Trel, including all the commands that are used, and uh, all the the whole process of it. And if you still like that as well, please sign up for a full featured developer platform. And if you have any doubts in getting things going, please reach out to us at reddit.com/r.trel. Thank you.